In the previous lesson, we had seen the magnetic field patterns due to various current carrying conductors. We had seen that magnetic field are lines of force which exert a force on any magnet kept in its vicinity. Do you think the opposite will also be true? In fact, Andre Marie Ampere also thought the same and even suggested that the magnet exerts an equal and opposite force on the current carrying conductor. In general, if a current carrying conductor is kept in a magnetic field, it experiences a force. Let us see this with the help of an experiment. Consider the experimental setup shown. In this setup, the aluminium rod is suspended horizontally from a stand and it is placed between the poles of a strong horseshoe magnet. Also, the field is directed upwards, that is, from the north pole to the south pole. Further, this rod is connected in series with the key and a battery. Now plug the key and pass the current in the rod in the direction from A to B. What do we observe? We observe the rod has displaced to the left. And now if I reverse the direction of current, the rod shifts to the right. What causes the rod to move? The displacement of the rod proves that what Andre Marie Ampere suggested is true. When the current carrying aluminium rod was kept in a magnetic field, it experienced a force. Also, when we reverse the direction of current in the circuit, the direction of force also reversed. Therefore, we can say the direction of force is dependent on the direction of current flowing in the circuit. Let us do one more modification to our experiment. Let us reverse the direction of magnetic field and let the current be flowing from A to B only. We observe the aluminium rod shifts to the right. This suggests the direction of force is also dependent on the direction of magnetic field. From the experiment we just performed, we conclude that the direction of force experienced by a current carrying conductor in a magnetic field is dependent on the direction of current and on the direction of magnetic field. Also, from various experiments scientists performed, they concluded that the magnitude of force experienced by a current carrying conductor is maximum when the direction of magnetic field and current are perpendicular to each other. If the direction of current and magnetic field are perpendicular to each other, then we can easily determine the direction of force by using the Fleming's left hand rule. According to the Fleming's left hand rule, stretch your thumb, index finger and middle finger in such a way that they are mutually perpendicular to each other. In this, the middle finger represents the direction of current, the index finger represents the direction of magnetic field and thumb points in the direction of force acting on the conductor. Now let us use this Fleming's left hand rule and verify the direction of force we saw in our experiment. In our experiment, the magnetic field was directed upwards, the current flowing in the conductor from A to B was inwards, therefore the force on the conductor is towards the left. Find it tricky? Don't worry, we'll use more of this in our next lessons when we study the working of an electric generator and electric motor. So let us quickly recap what we learned in this lesson. We learned that a current carrying conductor experiences a force when kept in a magnetic field, and also we learned to apply the Fleming's left hand rule.